Hi, everybody. I believe we should be online now. I'm a little bit late. But I will run to my working place so you will see our factory a little bit. And I hope we can start right on time. So let's hurry up. Ah, there we go. Won't be a second. Moin, Herr Sukok. So, I'm really excited to start this webinar with you. I believe the language will be English because there's a lot of international attendees, but we can also switch to German if you like. I'm here walking through our production hall. We've invested quite a lot of money in the last couple of years, and we're actually doing quite good despite Corona. I hope the same applies to you. And I'm very happy to share our new smart screw technology now. I hope you can hear me now. So we have some good big screws now for offshore applications, exciting stuff. And I won't be a minute and then I'm at my working desk. Hello. And there we are. Just about in time to start on time.
There I'm again. Hi, everybody. So I hope everybody can hear me loud and clear. If this should not be the case, then please just give me a shout. So we're going to start our webinar today and talk about smart screw technology. Let's just see a little video of what this is all about. Yeah, well, thank you everybody for joining. We got quite a lot of people joining now from all over the world. I think in total about 31 persons applied. So this is our third webinar, which works amazingly good. We're really excited to use this new tool. Although the video conferencing technology is nothing new, I must admit, I only started using it really in these Corona times. So as an opener, let me just briefly show you a little bit what we do. I know we've got some customers present, but we also got some companies present which do not really know what we do. I'm going to show you this in a brief couple of minutes by these slides. So what do we do? What do we actually manufacture apart from smart screws, which is of course the main focus of today's webinar? We do complex and large customized screw components. That really sums it up. We make screws, we're the screw nut guys, and we make everything custom made based on your individual specifications. And we serve about 54 countries now and serve about all industries that I've heard of, from the fish sorting machinery to nuclear power plants to underwater applications, you name it. So that's, for example, a nice example of a large screw by all means. I think the raw material was in excess of 4 tons, and this was used in some Russian energy plants. These are the countries. Sorry, this actually exceeded now. We got 54 countries by now we serve. So we are actually present all over the world, although Germany is still our core market. Yeah, these are some of the applications which we serve. You know, oil and gas is very dominant, and heavy lifting. Heavy lifting is one of our core applications. About 35% of our products go into heavy lifting applications. So, such as these ones. You know, these are on ships, some reels, which can be lifted up and down to reel up some big coils, or some reels, underwater cables, and etc. Or lifting jacks, train lifting jacks are one of our main applications. We serve companies all over the world. I'm very happy, and I think we've got an extremely high knowledge of the screw surface, how they have to be in order to achieve the best results for lifting applications. Subsea robotics also, I think this is a robot which goes down to in depth of 3,000 meters, stuff like that. Feed screws in all kinds of forms and shapes and sizes. And very crazy screws. I think that's the screw on the right that was 22 meters long. So let's talk about smart screws. What are smart screws? Why did we actually came to this subject? Why did we start thinking about smart screws? Well, a lot of our customers use, for the heavy lifting applications, use load cells. For some applications, they're actually mandatory by law in Germany, because if you have lifting platforms where there are people that work underneath, you need to be sure, you need to ensure 100% that you know when something is happening, you know, in order to save lives. And that means that if you have a lifting jack, you have to apply a load cell, which is extra equipment, extra cost, extra cabling, and extra reason for failures. So, and we thought, well, if you lift something heavy, something is happening in the screw, you know. It's like even though it's steel, it's still kind of rubber band, you know. It expands and it can be compressed. Even though it's extremely minimal, something is happening. And why don't we measure that directly where it's happening? Why don't we measure that in the material? And so we thought about putting you see here, like a kind of, how do you call it? Well, a schematic version of our sensor cartridge. We developed a small cartridge which can be included in the screw, and which includes some strain gauge sensors, DMS, also Denmessstreifen in German. And through these Denmessstreifen or strain gauges, we can actually measure what's happening. We can measure load, compression and force, and also torsion. And while we were at it, we thought, well, why don't we bang in another couple of sensors? Why don't we also measure, for example, revolutions? Yeah. Or we can also measure vibrations or positioning. And I'll show you all this in a live demo right in a second. But what makes the thing really, I'd say, sexy and interesting is that we have on-chip data processing. So we can define a threshold, a specific load, which you don't want to exceed or exceed, and just put on the light so you can see me more clearly. So I'm not in the shades. You can define a threshold, and whenever that threshold is overreached, then something is happening. An event can be triggered. Your screw can, for example, call a service technician. So by defining these thresholds, you can really make the screw intelligent. The same goes for vibrations. We can measure vibrations quite accurately. And vibrations are, I've probably got a lot of engineers here present. Vibrations are, often a sign of wear and tear. And if vibrations increase, it's normally, if you have designed a machine, it's not a good sign and you want to know about it. And what would be better as if your screw can actually tell you? We can define all kinds of events. The screw can send an email to a service technician. The screw can actually, inform the machine so that you reduce the revolutions or reduce the amount of energy that's applied, or you can shut down the whole machine. So all this is possible, and that's the actually really interesting part. And, it goes really hand in hand with predictive maintenance. Some companies, you have maintenance intervals, and you have to send out your maintenance technicians every year, once or twice. If you would know what state your equipment is in, maybe you can save the 1 or 2 times sending out your technicians, and you save costs. Wouldn't that be great? And let me just jump to the next slide, and then I'll show you the real McCoy. We got, at the moment, one of the first questions is always energy. How do you actually charge these things? Well, we got a battery inside, a 300 milliampere capacitor, a 600 milliampere capacitor, which is equivalent to a AAA battery. But we can also charge our screws via induction. And since the screws turn anyway, they can actually charge themselves automatically. Isn't that great? So that's so far so much about the boring PowerPoint part. Now I want to show you some real stuff. I'm going to switch the camera for that. Got another camera. And I'm going to pick up our demo screw, which is right here, which is one part we can actually bang the sensor in all kinds of screws. I'm going to switch the camera, then you can see it more easily. Hang on. There we go. And by all means, please always interrupt me when you have like, one moment, I have to, there we go. I don't get. I know that's just a mirror image of my display. So if you have any questions, and that's the beauty of these online webinars, then just ask them directly. We can solve all or answer all questions on the go while you're here, and that's what I'm here for. So we got a screw here. Hey, who's coming? Oh, hi. Let me just show you this. This is Lola, our dog. So we're a family business, so Lola always is coming and visits me and wants some cuddles. So say hi, Lola. Hi. Hello. All right. But now it's back to work. Okay. Come on. Up. Up. Yeah. Okay. I just rather close the door. By the way, I'm just going to pick up this PCB. So that's our printed circuit board, which is basically inside this cartridge. The cartridge is about 300 millimeter long, and it's included here. And there's a rubber thing on the top just to avoid that some water gets inside. And we have an app, but again, I'm going to show you something else. The app is something that allows you to monitor the condition of your equipment on the fly while you're in production or wherever you are. But of course, the signals can also be transmitted to a standard gateway, which is in your machinery closet, which can then interact with your internal systems or with your equipment, right? So the app is more or less like a gadget, but the sensor sends out a low Bluetooth low energy signal just saying, hi, I'm here, but it's not using up a lot of energy. And I can now connect the screw with the app, which I'm going to do now. Hang on, there we go. Okay, I'm just going to switch off the light, and you can see that better. There we go. So the gateway is now connected with the screw, and I can now see what's happening inside. Let's have a look. Oh, right, something is happening already. Okay, so I hope you can all read that quite clearly. Here we have like force in the beginning, we have torque, then we have X, Y, Z positioning, and RPM like revolutions, And I'm just going to start with force, and what I think is amazing how bloody accurate these sensors are. It's really quite crazy. So here you see a lot of data flickering, but if I'm just now going to grab the screw, just through the warmth of my hand, the steel is expanding, and we can actually see that. I couldn't believe it when I saw it the first time. So see, there's no magic trick, there's nothing, there's no hidden cable or so. I'm just going to grab it, and you see something is measured. Isn't that great? I mean, but if I'm going to compress this manually, you can also see that quite clearly, right? I pull on it, and you can also see that. And that's, not because I'm so strong, it's just the sensor is so damn accurate. What I'm applying here is less than a few kilos, I would say, at the most, And at least for heavy lifting, I think our customers, I think some of them are present, would agree, plus minus 25 kilos is nothing, at least in the heavy lifting applications. So that is extremely accurate, but that actually allows you also to see, to extrapolate a lot of other things, which I'm going to elaborate on later. Let's go to the torque, which I'm having here. And there we have it. So I'm going to apply some torque now. And again, you can see quite clearly that something is happening, right? And again, I'm talking about a few kilograms here, very, very, very small amount of force I'm applying. And just a couple of days ago, I had a very interesting video con with an extrusion company, and they work for a very famous pasta maker, in Italy. And they, use extruders for their food production, and they actually, feed the dough for making the pasta with their extrusion machines. And through the torque, you could really see in what the level of viscosity of the dough, it's quite logical, and then you can actually use this on-chip processing to control your machines. If the viscosity is too high, you add more liquid or water or milk or whatever, and if the viscosity is too high enough, then you stop the machine. So you can really use these sensors to regulate your processes and optimize your process. You can also ensure that your dough, which you probably received from a previous process, has a constant, the right viscosity all the time. You have quality inspections. You can use that sensors for quality inspections, ensuring that you have a constant process. All this is possible. In terms of lifting screws, or there's somebody else joining, I'm just going to let him in. In terms of screws used for lifting jacks, we actually realized that you can also use the torque to identify different lubrications. Lubricants are, for many of our applications, of extreme importance. Sometimes design a very expensive machine and define a very expensive lubricant containing graphite and silicone, and from Kluber lubrication, probably quite expensive, but really good high performance lubricants. And then you send the machine to India or anywhere in the world. And what do? Well, they use the old grease they use always. They have used for the last 10 years. Your machine will break down because the surface compression will increase. The lubricant will be squeezed out, and you have a cold welding, and you control away the machine. And who will call you? Well, your customer. Well, because they will blame you. Of course, they will not admit that they used the wrong lubricant, but they will just say, well, the machine was of inferior quality, and you have no means of proving it. Well, now you have. That's all things, values you can really use, and you can, what is important to sell stuff, you always want to be better than your opponent. You want to have no USP. And you have two machines, one with an intelligent sensor and one without. Guess which machine you would buy. Another point which I'm going to come to is now the XYZ. Let me just go to Z, and because that we can show that quite nicely. Well, that again, you can see, I'm moving it. You can just increase that so you can see it more clearly. But it's actually so accurate that you can even see vibrations. Look at this. I mean, isn't that great? If that amount of vibration is being picked up, you can actually use this to analyze your processes and see, well, in combination with overload and vibration, you can again extrapolate that there might be some wear and tear going on, and you should actually inspect the machine or have some maintenance intervals. Show that again, you even see the table, that is like vibrating after the initial impact. Yeah. All right. XY is, well, we can't show that here directly so easily, but we can try. We have to use a different diagram for that. Let's use a multi-chart. There we go. See if I'm now moving that. I don't know where X and Y are now, but you should at least, well, you see that something is happening. I'm going to clear that again. So it can be relevant for positioning. These are through acceleration sensors. You see very small movements are being picked up directly, and you can see if your equipment is installed in the right manner. And last but not least, RPMs, revolutions for us, of course, are always equivalent to distance traveled, because we always think in terms of screws. By all means, by the way, these sensors, sorry, there's 2 more people joining. I'm happy that you are there. So I think both have joined now. One moment. Yeah, one is still joining. So revolutions are for us important, or for us equivalent to distance traveled, and you can see how accurate this is. I can't really move the screws in such a small manner that it's not being picked up. Just take this part as a reference point. I'm just going to try to really, you see, I find it really difficult. I mean, even a millimeter is like picked up instantly. And of course, if I turn it, then it's being picked up, you know. And then you can really define, of course, distances, maybe regions where your screw should not be, where the nut should not be operating, you know, travel to. All this is, again, possible. So I see the main application really at the moment in torque, because torque like to identify, like I said, lubrications, for example, but I'm also very interested, of course, in your feedback. Maybe I've missed something. Just for the people that joined last, I'm just going to demonstrate the force in the torque again. Here, the force, you know, being so accurate that it's really picking up even the heat of my hand, you know, just expanding through the heat of my hand. That's amazing, you know. And of course, but also when I'm like compressing or, you know, stretching it, you can very clearly see that all this is being picked up by our sensor cartridge, which is included in the middle. It's all being transferred by Bluetooth Low Energy, which is not the Bluetooth we use in our phones, which is an industry standard, and transferred to our app, or like I said, to our industry gateway, which can be connected to your machine cabinet and can then interact with your internal systems. And well, for those who joined later, the fantastic part about this, I'm going to send you that presentation, is that we have on-chip processing. So whenever some threshold is, you know, reached, you know, a safety area, then we can trigger events. You know, your machine can actually shut down. It can be, you know, reduced in speed. It can call a service engineer. Whatever, you know, you can define what's happening. And just last but not least, the torque, because I believe the torque will be actually the most relevant for a lot of our companies, a lot which also work in the extrusion business. Here again, I'm applying torque, and you can see, bang. All right, you know, very clearly that's shown. By the way, one thing I forgot to mention at the beginning, we recorded this webinar. If any of you don't want this to be recorded, or, you know, then just let me know. Then of course I will not publish it. If you're fine with it, I would just put it on YouTube, so probably some other people can view it too. And what I'm interested in, by the way, we even got well, it's nothing but honor and pride, but we got a prize, about innovation prize for this smart screw technology, which makes us really happy and shows us we are going in the right direction. It's nothing that we've kind of developed in an ivory tower, which nobody is interested in. Actually, a lot of companies have a high degree of, or high interest in this, and we start cooperating with a lot of companies worldwide now to introduce this intelligent screw technology into their machines. I'm going to switch back to the other screen, but of course I'm also interested if, you know, if any of you have maybe some other applications that we didn't see, or some questions about this technology, something that I've missed in my initial presentation. So some of the questions, maybe I can also, but always interrupt me, by the way. Some of the questions is of signal strength, you know, how long does that stuff actually can send the data? We have a signal reach of about 30 meters now under ideal conditions, but I believe a reach of 30 meters should be okay. If we use a repeater, this can be, of course, extended indefinitely. Well, I'm going to send all the guys that attended my slides and also some specification sheet. We got some specification sheet outlining the most fundamental questions that many of you have. We are at the moment, we have one application now in the field and several samples in the field. So we are still, the design is still a little bit fluid. We actually, before Corona, we wanted to fix it by the mid of this year. Now we're going to fix it hopefully by the end of this year, but we're very interested to receive further information from you, from the market. We initially thought about adding a temperature sensor, which is actually still published on our webpage. This is kind of still being decided if we should add some temperature sensor or not. For some applications, it can be extremely interesting, especially in combination with the other factors, you know, vibration, overload, and temperature. And so this is still to be decided. Another thing which we're going to add shortly, which we're going to publish also, is a new antenna. So at the moment we have an antenna here, just here, and we're going to have a ring antenna which will allow for a better signal. And this is just a sample. You know, we can bang this sensor in any kind of screws like that in your design, and we can also provide this as a white label. So there does not need to be any Bornemann on this. You know, we can provide the app, we can sell the app to you with your company logo on it. So all that is absolutely possible. You know, and I see this as a strong differentiation factor. So you can really differentiate yourself from the competition. And we believe that in the next 5 to 10 years, sensors in machines is something completely normal. And it now depends on who is going to be the first, who's the first that can offer this in their machines, who can bridge, you know, the level of our technology now to the industry 4.0 standard, which will be the next level of all machines, you know, machines interacting, machines gathering data. And we even thought, there was a nice article in the Handelsblatt. I don't know how many Germans are here. So Handelsblatt, probably very renowned German newspaper. And we actually had a half a page with a big picture of our company and our smart sensor technology. And this was also mentioned that we even consider this could be even a completely new line of business. We could actually start offering our customers to sell them data, you know, about their processes. We could, or you could just bang in a sensor, and this doesn't need to be a screw. It can also be any kind of steel component. You can bang in our standard sensor cartridge, collect data, and then ask your customer a couple of years later, don't you want to know the data? Because I know now more about your processes than your engineers. Wouldn't that be great? And that's something that we are thinking about, offering some kind of consultancy, because through the interaction of these sensors, we find out more things about the machines, or we find out things about the machines which we previously did not realize, you know. Yeah, that's about a wrap. That sums it up. I think Mr. Santa Maria was joining a little bit late. I'm going to show this once more, the demo, but then I'm just going to wrap it up and send you the presentations. I'm really happy that so many joined. I didn't expect this at the beginning. We have really a big crowd joining. That's fantastic. That's really great. And we're going to use this tool of webinars more often for sure. So here again, I'm going to switch the camera to my smart screw. There we go. Here, I don't know what is now being measured. I'm just going to go back. Here we have the different things that are measured on live. You know, this is the screw is connected by Bluetooth to this app, which is just a neat way of showing, of measuring the data, which actually is also nice for your service engineers. Imagine, you know, you can go with the app on your phone to your machines and just see what's happening inside. So again, for us, I can see here. So I'm just stretching it again, oh yeah, and compressing it. And very clearly I can see that. I mean, I don't know how many thousands, how many microns I'm actually achieving here, but it is really next to nothing, and I can measure it very, very, very clearly. And torsion. If any of you, by the way, have some projects for which this could be applied, they're very interesting also to get some development partners. Yeah, we want to have, the plan is to have at least 50 of these smart screws in the field within the next year. So you're more than welcome, and I think we can offer very preferable conditions for the first people joining, because the more we learn about the smart screws in the field, the better they're going to be in the end. Here I'm going to apply torsion, and also this you see again is extremely clearly seen, and you know, I got sweaty hands. I don't have the tightest grip, and this is really nothing I'm applying here, you know. Even with using just a couple of fingers, you can see that, you know. The same goes for vibrations, which I think is also, yeah, quite useful. Ah, sorry, I just have to, that was wrong. There we go. Okay. Now that's Z. And again, even minimal vibration is clearly seen. Well, that's maybe too much. Well, that's you know, that's the benefit of it, and detecting wear and tear through that. Yeah. All right. I asked one more. Oh, sorry. I asked one more time if there are any more questions.
I've got a question. Would you be able to be measuring the dilation it has with temperatures as well?
Yeah, I just mentioned this before. We had a temperature sensor included, and then we took it out again. So it depends. This is actually something we have it still on our webpage, I know, but for this prototype, we've took it out. It still needs to be decided within this year if we should add a temperature sensor or not. It depends a lot on the feedback of the market. If a lot of companies want the temperature sensor, then we can, of course, include it, but that's still pending. And may I ask what kind of applications you are, or what kind of business you are in?
Well, we work on CNC for aeronautical and space.
Ah, okay.
It's basically to control the dilation and the, sorry, my English is a little bit scrappy lately.
No problem.
The dilation and how the compensation, the temperature compensations should be to be keeping the accuracy in the machines.
Ah, okay, I see. Very interesting. In the last webinar, we had also Airbus helicopters present. They were also quite interested in this. We have to think about it. Of course, we can also, after this webinar, engage in some more detailed discussions. And of course, we can also realize some customization if that's requested by yourself. Yeah,
that's pretty cool.
We have also some customers in the aeronautic field. Some customers, for example, use screws for opening and closing the flaps. You know, and for them, the screw is a very extremely critical component because if the flaps don't move, you cannot land. And so they are also quite interesting in measuring what's happening inside of the screw. You know, if there's a higher degree of torsion, maybe there's, you know, the screw is freezing and you know, you can't move the flaps. So in all these applications, we're working also on now.
Thank you.
No, pleasure. Anybody else? Just again, for those who joined late, I'm recording this, and if you don't want this, then of course we can delete this. Otherwise, we would just post this on YouTube or LinkedIn for those people who couldn't join today. But just let me know. I'm going to leave that until the end of the week. And if I don't hear from you, then we would just post this for other people to join in. And of course, we're also going to repeat these webinars because they prove to be a really comfortable tool to reach a lot of people all over the world at the same time. And I hope you enjoyed it as well, just like me. I really had the pleasure of showing you this technology. Yeah, and I'm looking forward to engage with many of you, hopefully also after this webinar, after I've sent you the presentation. I think we have your email addresses. I just have to see, because if you registered on Zoom, then I got your email address and I can send you the PDF version of my presentation. Yeah, then I remain with my very best regards and wishes, and yeah, hope you all stay healthy and get through these very crazy times. And yeah, thank you for your time and joining us. I'm very honored. Thank you. Bye-bye.
Bye. Cheers.